Picture a future where machines not only grasp our language, but also craft it with remarkable finesse, where creativity knows no bounds as artificial minds effortlessly generate images and ideas. This isn't the stuff of sci-fi dreams. It's the emergence of generative AI, a tool that will complement and benefit us in both our work and our everyday lives. To gain a better understanding of generative AI, it is crucial to dive into its foundational technologies such as machine learning models and their architectural nuances. Let's get started by exploring the distinguishing features of generative AI. Unlike traditional AI, which typically focuses on analysis and classification, generative AI is proactive in creating new content. This shift from passive analysis to active creation is transformative, especially in handling complex tasks such as natural language processing or NLP and synthetic image generation. NLP enables machines to read, understand, and generate human language, while synthetic image generation involves creating fake images using computer programs and algorithms. It's like a digital artist creating a convincing picture of a landscape they've never seen before. The introduction of transformers, a type of model architecture that relies on mechanisms called attention and self-attention, has revolutionized NLP. Models like Google's bidirectional encoder representations from transformers, or BERT, and OpenAI's GPT series use these transformers. They learn the relationships between words in a text, but not in the usual order from start to end. Instead, they can understand different parts of the text at the same time. It's like reading a mystery novel and being able to pick up on clues scattered throughout the book all at once. This way of learning allows for more things to be processed at the same time, making the training quicker and more efficient. So those are some of the distinguishing features, but what are the technical foundations of generative AI? It primarily operates through two types of machine learning: supervised and unsupervised. In supervised learning, models are trained on labeled datasets, allowing them to learn a function that can map input data to desired outputs. For example, a model might be trained to generate text summaries by learning from a dataset of articles paired with their respective summaries. Unsupervised learning, on the other hand, involves training models on data without explicit labels. Here, the aim is for the models to discover inherent patterns and relationships in the data. This approach is particularly beneficial for generative AI, as it allows the model to learn to create content that is not bound by predefined labels, enabling more innovative and adaptive applications. Next, let's take a closer look at some of the core technologies behind generative AI. At the heart of its capabilities are neural networks, particularly generative adversarial networks or GANs, and variational autoencoders or VAEs. Variational autoencoders or VAEs encode input data into a compressed representation and then decode it back to reconstruct the input. The process involves optimizing the parameters of the encoder and decoder so that the output closely matches the input, allowing the model to generate new data samples from learned representations. Language models are constantly evolving, so it's important to keep up to date with these advancements. Language models such as GPT-3 and BERT demonstrate significant advancements in generative AI. These models use transformer architectures, which rely on self-attention mechanisms to process sequences of data, like sentences, in ways that consider the context provided by other parts of the sequence. This is crucial for generating coherent and contextually appropriate text. Word-to-vec, another critical technology, involves vectorizing words into a geometric space where words with similar meanings are located close to each other. This enables more nuanced understanding and generation of text based on semantic similarities rather than just syntactic rules. Generative AI has many business applications and can revolutionize several key areas. Let's explore some in more detail. Firstly, there's content generation. GPT models excel in generating written content by leveraging transformer architecture, which allows them to understand context and generate coherent and contextually appropriate text. These models are pre-trained on a wide variety of internet text and fine-tuned for specific applications, enabling them to create high-quality articles, blogs, and other written materials. Next is personalization. The process starts with collecting user data from sources like websites, apps, and social media. Integrated data pipelines using tools like Apache Kafka or Google Cloud Dataflow consolidate this data in real time. Real-time analytics platforms such as Apache Spark Streaming or AWS Kinesis process the data to extract insights which feed into a personalization engine that generates tailored recommendations, content, and communications. These personalized interactions are delivered using APIs integrated with various platforms. To ensure low-latency responses, edge computing technologies like AWS Greengrass or Azure IoT Edge process data closer to the user. Additionally, there's automation. AI models trained on large datasets and using advanced algorithms automate these processes, improving efficiency and reducing costs. The technical backbone includes robotic process automation or RPA for executing repetitive tasks, AI-powered software tools for intelligent decision-making, and cloud services that provide the necessary scalability and support continuous learning and adaptation of the models. This infrastructure ensures that AI systems remain up-to-date and can handle increasing volumes of work effectively. And finally, innovation. Generative AI fosters innovation by simulating and modeling various scenarios to predict outcomes, aiding businesses in developing new products and services with higher success rates. This involves using advanced AI models for predictive analytics, scenario planning, and risk assessment, including techniques like regression analysis, time series forecasting, Monte Carlo simulations, Bayesian networks, and stress testing. Large datasets from diverse sources are processed using tools like Apache Hadoop and Apache Spark. Simulation tools such as digital twins and optimization algorithms are used to predict performance and find optimal solutions. From what you have learned in this video, it is clear that generative AI is a powerful tool that, when leveraged responsibly, can provide significant advantages to businesses by automating tasks, personalizing customer experiences, and driving innovation. You've gained an understanding of how generative AI continues to evolve, providing useful business applications. As the technology continues to evolve, it will likely become an even more integral part of the digital business landscape.